And finally, let's take a look at how some of this mental math and some of the strategies and properties of multiplication and addition can help us make calculate with larger numbers. So for example, if we have 6 times 38, how could we use what we know from multiplication in order to figure out how many dots there are? So if this is 6 times 38, children generally are able to multiply things like 6 times 30 or 6 times 8, right? 6 times 38 is based off of that. So if we're able to split up this rectangle of dots into 8 and 30, then kids are going to be much more better able to tell you that 6 times 30 is 180 within here, or 180 dots. And then within the second rectangle is 6 times 8 is 48. And then so together it's going to be 228 dots. Right? So that's something that children will quite readily do. So using the distributive property then, when we did 6 times 38, what we actually did was 6 times 30 plus 8. So 6 times 30 plus 6 times 8, and there's our 180 and 48 and 228. So that's really doing this picture, drawing this picture and splitting up one of the dimensions into tens and ones allows us to visually represent the distributive property. Now, if we do the partial product method, 38 times 6, with partial products, if you remember, if you're familiar with partial products, so we did it earlier on in this chapter as well, we would say, what's 30 times 6? Well, 30 times 6 is 180, and 8 times 6 is 48. And we actually write down all of those numbers, and we would then have 228. So there is our partial products strategy. So notice that all three of these strategies, whether we're looking at partial products and looking at 180 and 48, whether we're looking at the distributive, we get 180 and 48, or we're looking at the visual array, looking at 180 or 48. All of those strategies are actually showing that connection quite readily. So with much more generalization, now if we look at two-digit numbers times two-digit number, so for example, 23 times 45, we can do a similar thing, a similar strategy where we write our tens and our ones, tens and ones, and then we will multiply, we'll find the area of each one of those regions. So this would be the 20 times 40, and kids know how to do that. So we would have 800 pieces there, or 100 cells there. This would then be 20 by 5, so that's 100. This would be 3 times 40, 120, and this would be 3 times 5, 15. So now what they would do is they would say, well, the whole total is going to be 800 plus 100 plus 120 plus 15. So that's 800 and 100 and 100, that's 1,000, and 20 and 15, so 1,035. So if we're looking at distributive property, 23 times 45, so we can do distributive property in a number of ways. We could do 23 times 40 plus 5, so that would be 23 times 40 plus 23 times 5, times 5. And then what we would say is, well, 23 times 40 is kind of is much more is not much easier than the original multiplication that we had. So we could say 20 plus 3 times 40, And same as 20 plus 3 times 5 here. So we have 800 plus 120 plus 100 plus 15. And that again gives us 1,035. So what we're looking at here again is the 800, the 120, the 100, and the 15. And you notice them. Oops. Pardon me, apparently my mom was looking through my photo album. And what you notice is those same numbers coming up as the regions, the rectangular regions in the multiplication array. Now, what this is asking is now let's connect other algorithms as well. So for example, partial products method to calculate 23 by 45. Well, let's take a look at this. So if we do 20 times 40, we get 800. 20 times 5, we get 100. 40 times 3, we get 120. And 5 times 3, we get 115. And notice that those are exactly the same numbers that are coming up that came up here. So all of those methods are actually connected with each other. And so the total would again be 1,035. All right, so let's, I've deactivated those notifications, so let's come back to the standard algorithm. So 23 times 45. The standard algorithm tells us that we need to multiply by 5. So 3 by 5 is 15, and it's going to say carry the 1 or put the 1 above. And 2 times 5, and we remember that that 2 is not actually 2, but in the standard algorithm we say 2 times 5 is 10 plus the 1 is 11. Okay, and remember that's still not 10 and that's not 1. It's actually 100 and a 10, so we have an issue with the connection to real world and the meaning of the number. So then we're going to say we're going to bring down a 0, or we're going to place a 0 there. And again, there's no connection as to why that happens, or we need to do that. And then we'll say we're going to cross this out because that's no longer, that was for the first product. So 4 times 3 is 12. And carry the 1 again, whatever that means. 2 times 4 is 8. And add the 1, 9. So what's happening is that 2 and the 4 are not 2 and 4. They're 20 and 40. And they're not 8, they're actually 800, and carry the 1, I'm not sure what that is, it's certainly a 10, so then we add the 2, and we get 10,035. And notice that in here, those numbers actually do not really connect nicely to anything else that we've done in any of the previous algorithms. I mean, they're in there. There's the 920 and there's the 115, but it's not clear that connection is hidden. And most kids just memorize the algorithm without actually taking the time to make that connection. All right, and finally, what you need to do is, what the question 8 asks you to do is do the calculation 46 times 53 using all of those other methods that we've done in 1 through 7. All right, and if you have any questions on those, let me know next time we see you.